Hello, everybody, and welcome to my Lunch and Learn. I'm Vince Marino, and this is my Lunch and Learn. My guest today is Andy. Andy's with Electro Static Technology, and he's in Brunswick, Maine. And the product that first caught my attention was the AEGIS um, discharge. How do you call it? Shaft grounding ring. Andy, is that
That's
right?
correct, yes.
Why don't you start by telling us a little bit about yourself and about the Aegis product and electrostatic technology in general, and then I'll give you a couple of questions about where it works, where it doesn't work, how do you know where to deploy your product. So start from the beginning. I hear
Right.
you're in Brunswick, Maine, right?
Absolutely. It's not a bad day in Brunswick, Maine. A little bit of snow on the ground and not too cold either. So my name is Andy Kressbach. I am the sales manager for the North American industrial market and have worked for Aegis for probably just about 15 years now. Um, Most of my previous work experience has always been in heavy equipment, industrial, commercial, um, in all types of equipment with several different companies. But Aegis is one of those. Aegis is one of those companies that I came to about 15 years ago that really piqued my interest because not only do we have a excellent group of people there, but we also have a really driven marketing team to make sure that this gets out to the market. Aegis is a product that was developed in 2000 or 2002. Um, ITW, or Illinois Toolworks, is the parent company of Electrostatic Technology, and they acquired the assets of EST, or electrostatic, and then had a project. And that project was, why do motors fail on drives more often than motors running across the line? So that's how it got started. And with an excellent group of marketing, sales, engineering, and production staff, we were able to make a real impact on the market. So from 2002 till today, it is a global product, and it is used worldwide with just about every motor manufacturer out there.
Wow, that's quite a feather in your hat there. I was just looking at your website, and then I also wanted to share. Here's the first thing that I saw that came up, and of course, you guys are a great advertising partner with us here. This is one of the pages of our recent magazine, Empowering Pumps, and I'm looking at this right here. This is a couple of visuals, give the folks an idea exactly what does it look like and how does it work.
So here's what it looks like. This is a shaft grounding ring. It's just mounted on a Lexan plate. The shaft grounding ring basically fits around the shaft on an electric motor. It doesn't matter um, what size electric motor it is, but the function of that shaft grounding ring is to make sure that you take the electrical charge off of the rotor shaft before it wants to go through the bearings. This shaft grounding ring here was invented in about 2003, and that shaft grounding ring has uh, there's different sizes, different types, different shapes, all that kind of thing. Just depends upon what you have. But how it works, and this is kind of interesting. Um, when ITW came to us and said, "Hey, we've got a project for you," that we noticed that in the global market, that motors running on drives do not last as long as motors running across the line. So motors across the line, just regular wired in and running at 1800 or 3600 RPM. But when you use a drive, or what's known as a VFD, variable frequency drive, the VFD has the potential of creating some problems for the bearings. Now, a lot of times people say, well, there's no electrical wires that run to the bearings. So these, how can you have electrical damage? The fact here is that when you have small amounts of electrical charge produced by the VFD that are not being used for the rotation of the shaft, the rotor, acting as a capacitor, picks up those small electrical charges. And those electrical charges, once they've built up far enough, they want to dissipate or follow a path, the least resistant path to ground. That being the case, a rotor of a motor only is affixed in 3 points: non-drive end bearing, drive end bearing, and then if it's connected to a pump or a gearbox or whatever, down the shaft into your driven equipment. So the idea here is that if we pull off that electrical charge before it gets a chance to go through the bearings, it is very effective at, number one, creating the situation where you don't have premature failure in your bearings. And the second thing that happens here is that it gives you a lifespan which is much greater than it would be if you had electrical discharge through your bearings. It can happen in as little as the damage can happen in as little as 2 weeks, 2 months, 2 years. It really depends upon the motor and depends upon the specific situation you have. So
So,
that's how the damage actually takes place.
okay. So, question for you. First of all, is it possible to notice a difference just using the human ear, for example? I got a brand new motor. I hook it up to a VFD. I run it, and then I put one of your rings on there a week later. Am I going to notice anything, or is it solely via a oscilloscope that you can determine a difference with the ring?
The if you ran a motor on a VFD and then put a ring on it, there would be no difference in the sound. That electrical charge that's built up on the rotor and then dissipates through the bearings does not have a specific sound. But if you have premature failure in your bearings, once you rough up the inside of that bearing, you can hear a rather annoying sound where a bearing is not running smoothly. But if you have a new bearing, no, there's no difference in there.
Okay, excellent. All right, so maybe you take me through a story where you went to see a customer, they were not using your product. What was what was the problem stated, and when you walked in and repaired, what was the outcome? I mean, was there a quantifiable dollar savings or lifespan increase? And just give me an example of a couple of success stories that you yourself have been involved in.
Okay. First of all, take for an example something like a paper mill, Georgia Pacific and Savannah River. They have lots of large motors, lots of small motors. I think that mill is probably one of the largest paper mills in the U.S. And basically, they take pulp or wood fiber, turn it into paper, and they use the standardized process for this. And they have probably about 2,000 to 3,000 motors in a typical paper mill. So I was actually at a motor repair facility, and I had asked the people there who owns these big motors, and they're like, oh, these motors come in almost weekly from Georgia Pacific in Savannah River. So I was like, okay, well, what's going on with them? And they said, well, every year or two they have to bring them in and rehab them because the bearings have premature failure in them. So obviously, my next question was, okay, who have you been talking to at Georgia Pacific? I went to actually down to see them, and a guy by the name of Rick Altman, who's the plant electrical engineer, said, "Yeah, we send these out. That's what we've always done." So I said, there is a solution to this. The bearings in these motors that you have, and these happen to be 1,500 horse motors, the bearings in there are all what are known as L10 bearings, meaning they have 100,000 hours of operational lifespan if you treat them nicely. If they're running, so they're getting a really short amount of runtime out of these before they have to rehab them. Plus, they have to have spare motors, and at the same time, it takes a fair amount of dollars and manpower to change out a motor. So you have downtime, you have labor, materials, all kinds of stuff. So we actually, when we talked to Rick, I said, if we test with an oscilloscope is going to be the gold standard for knowing what's actually going on. So we took an oscilloscope out onto the floor and tested some motors. And I said, don't tell me if a motor has a problem or not have a problem. And the scale of the problem, here's kind of an interesting fact. If I took 100 motors and lined them up on the floor and put them on or in a VFD and ran those motors either under load or not under load, and it doesn't matter the manufacturer of the motor, the horsepower, the voltage rating, any of that kind of stuff, what we find is that we can find an actual discharge trace about 50% of the time. So that means that 50% of the motors out there that are running on VFDs have an issue. And if you don't do something about it, it tears up the bearings, and then eventually you could have a pretty severe motor failure by not doing something about it. So we actually, they were pretty reluctant at first. And I said, well, try it. You have no skin in the game here. I said, it's all upside for you. Try it. So that was about 3-4 years ago. And since then, they have done every large motor in the facility without exception because it did work. Now, it doesn't matter whether it's in a paper mill, a steel mill, a HVAC fan, a dog food factory. It really doesn't matter. What matters here is that when you have motors running on drives, you have about a 50% chance of having a problem with that motor with prematurely failed bearings. So that was one specifically. I'll give you another specific situation. We had a steel mill in Roanoke, Virginia, that had bearings that were constantly going out. They have 900 horse and 1,300 horse production motors, and these guys are doing everything from railroad ties to, all kinds of different steel products. So they were actually having to rehab their motors in under a year. 9 months is about the average of what they found. So
can I ask you, what does that translate into hours? If in the previous example, you said 100,000 hours
yep.
That was being unable to be achieved. So what would a typical motor lifespan be in hours over there?
So in hours, if you have 100,000 hours of functional mechanical wear time in a bearing, that's going to list out to be somewhere between 10 and 12 years running at 1,800 RPM. And that would be continuously. So if you had a bearing in a motor that was failing after 6 months or 6 weeks or 6 years, one of the things that you want to look at is, number one, does it have a VFD? And number two, am I hearing any sound coming from those bearings? Once you determine that you have that issue, then you have a proper diagnosis is going to make a big difference in getting down to the heart of the problem very quickly.
Okay. So you're at the steel mill. They're going through they're going through these motors at a fairly rapid clip.
Yep. And if you know anything about commodity products like steel and paper, you don't want to shut those mills down. You want to keep them running 24/7 unless you are up against a hard repair date or unplanned. And that's really what AEGIS does is it creates the situation where, number one, you have motors that are going to operate to their full potential. Number two, it decreases your cost dramatically when it comes to repair. But the really big cost is what's the cost of downtime? So, say you're in a tire plant and you're making tires and you have a whole bunch of downtime because your plant is broken down. That gives your competition the ability to go out there and take advantage of you. So, the whole idea here is to make this commodity process, this manufacturing process, as efficient as possible. And the reason you can do that is by keeping your motors up and running. There is an attitude out there that, well, this is the way we've always done it. So when I've talked to people like at Steel Dynamics in Roanoke, Virginia, I've simply said, look, try one, okay? Take your worst case scenario. I understand that you have open bearings, so there's a lot of grease that comes out, those kinds of things. Um, we will supply you with that, put it in, and we'll also come back and test it. Um, that was an actual situation, and I think they're on their. These are the larger motors, so they use a much larger ring, more expensive. I think they've done 22 of their motors so far with no issues of extra downtime or that kind of thing.
Yeah,
So
Andy, let me ask you real quick. I don't want to. You're telling a great story, but can you hold that ring up again? It really close to the lens for a minute. I just kind of want to look at that thing and see. Yeah, so I'm looking on the interior. I'm guessing that's some kind of like a fiber of some kind on the inside ring where it actually comes in contact with the shaft. Is that right?
it is. Let me explain
Yeah,
the
please.
actual
Yeah.
product itself. This is an aluminum housing. This one happens to have brackets on it, and those brackets are basically allow you to stand off if there's a shoulder on the shaft of the motor. But the black conductive microfiber that's actually on this ring is a highly conductive fiber. It will transmit an electrical charge very well. In this ring, this is not a very large ring. We make them up to, we made them as large as 48 inches in diameter for hydroelectric and that kind of thing. But a ring like this is will last 200,000 hours. And we publish that. So it'll last double the lifespan of the actual bearings in the motor. And on a regular basis, we have people ask us, hey, can I take it off of this motor and put it on that motor? It's the same shaft size. I'm like, yep, if it's not worn out or full of grease, you're in good shape to take care of that. So conductive microfiber. We also make these out of stainless steel. Um, we have all different kinds of products that say they have different coatings on them, that kind of thing. Some of the places that we've actually gone with this, the Mars rover, Generation 1, which is on Mars right now, does not have shaft grounding rings. And it is basically tearing itself up because each wheel has a motor and a VFD associated with it, so they can move in a lot of different directions. Well, they just completed the second generation Mars rover, and I'm not sure exactly when it's going to be sent up there, but the second generation Mars rover has stainless steel shaft grounding rings on all four wheels, so that they can make it last longer on Mars. You can't bring it back for repair.
I love that. That's a great story. So going back to the steel mill for a minute, you said that you had to make a fairly large diameter. How big, what kind of diameter are we talking?
Those are typically 9 to 12-inch diameter shafts, but it really doesn't matter. We work in a lot of power plants that have 15 and 18-inch shafts. Nuclear power generation, a lot of they have 9,000 horsepower motors. So if you can't get to the shaft, you get to mount it on the coupling. Coupling can be 22 to 24 inches. So those are all pretty standard sizes that we've done. And like I said before, we've been probably as big as 48 inches now for the big shafts that are in the generators in hydroelectric projects also.
So, question for you is, are OEMs starting to incorporate the product into their end product? Motor companies, for example, are they taking the product and saying, now buy our motor, it includes an AEGIS device? I mean, is that happening, or do you have to buy that independently?
It can be done either way. If you are looking for a motor with one already mounted in, we started working back in 2004 with motor manufacturers, and they adopted it about 2012, somewhere in there. So Baldor or ABB was the first company. So currently today, the only company that doesn't use AEGIS is Siemens in Europe. But every other company, doesn't matter who it is, uses AEGIS. And there's two ways it can be put in. There are some motors are actually mounted up right on the production line with AEGIS. And the result of that is that you can purchase that right off the shelf and they're ready to go. The other way is that you can request a mod from a motor company, and that mod is simply they take an already completed motor, put a shaft grounding ring on it to your specification, and then ship that out. And then, like you said, it could also be added after the fact.
Right. So the idea then is, I'm visualizing with, for example, the pulp manufacturer or the steel industry, uh, as a salesperson. They walk in, they talk to if there's a preponderance of motors going bad, they say, do you use VFDs? That's part of the equation. The VFD is actually contributing to it. And of course, then they recommend the shaft grounding ring extends the life of the motor, and you stay in production longer, and everybody wins. I don't see why. I mean, to me, it's almost like, why doesn't everybody just have these? I mean, is there any resistance? I mean, I would think that it's like, you know, when we were kids, there were tires, and then somebody had developed a steel belted radial tire, and that made it better because all these reasons. So now it's sort of a household item, right? So is
Yes.
there is there any resistance to this product at all? It just seems like it would be a win-win for everybody.
There is resistance to it because for several reasons. Okay. Number one, it's something that people look at and go, oh gosh, I didn't even know I had this problem. But let me take another step back here.
Sure, sure.
If you have motors in a production facility, I don't care what size they are, whether they're 2 horse, 10 horse, 20 horse, 200, 2000, doesn't matter. And you're running them on VFDs, you have a 50% chance of having premature bearing failure. Now, why is that important? Because there's a lot of times that customers don't know that they're having these problems, and they go down all kinds of rabbit holes looking for, gee, do I have a lousy motor? Do I have you know, do my mechanics know what they're doing, or my electricians, those kinds of things. There's also uh, a situation where you get into big plants like Georgia Pacific and Nucor Steel and that kind of thing. These are typically not run by young bucks. They are out there. The engineering and mechanical staff are typically well-seasoned individuals, and they do not want to change things. If things are working good, they want to leave them the way they are. They just don't know that they can actually make things work better. And that's what we do, is we actually talk to them and say, hey, look, try this. If it works for you, great. We've got an excellent track record of making it work. So there's not too much of a problem, but it is a educational process to actually make this happen with um, uh, pretty much any type of customer. One, they don't know, um, or two, they're they don't want to try new technology out there. Is what it comes down to.
Right. FUD is fear, uncertainty, and doubt. FUD
Yep.
is a lot of people are, which is a shame, but yet I get it. Sort of a human aspect of it. Let me ask you: do you, when you do this kind of thing, it sounds like it's educational more than anything. Do you have some kind of a, gosh, like a shop or a classroom example? I don't know what I'm trying to say. Like a training academy of some kind. Do you have a, is there anything that you do, or is it literally one on one where you go in, you talk to a manufacturer and or a production line person and say, look, this is what how we detect it. Here it is. I mean, how does that work? Is there a class? Do you go in? Is it one one by one you go into prospective clients and talk to them, or can you? Because this
It
is a
actually it actually works both ways. When you have a large facility like Georgia Pacific in Savannah River, you want to know who the electrical engineer is for the plant. Talk to them and say, hey, look, have you ever seen these problems? How often do you repair your motors? So you can break it down that way. The other way we do this is that we have webinars that we run on a regular basis, and they typically have a specific background to them. Things like wastewater treatment, or large electric motors, or production facilities, or conveyors, those kinds of things. So we focus on some specifics, but the basics are all the same. When you have an electrical charge that is attracted to the rotor, builds up on the rotor, and dissipates through the bearings, really doesn't matter what you produce. The motor is what's failing. So by using AEGIS shaft grounding, you defeat the electrical charge by simply pulling it off before it gets to go through the bearings.
right.
So it's both ways.
Yeah. So I was kind of poking around and I saw this. This is sort of a 60-second summary of what we're talking about. I mean, this is the look at that.
That's exactly what we're talking about. It creates the damage. And once that damage is inside of the bearing, there is no solution for repairing the bearing. The bearing has to come out and be replaced. So by using shaft grounding, and just as you have an example up here, this is on the drive end of the motor. It can be on the non-drive end of the motor, and it can be inside or outside the motor, either way.
Wow, look at all these folks that use you too. Yeah, ABB and the like. Let me ask you a question about the bearing. This is interesting though. I mean, can the material that the bearing is made out of also have be a factor? What I mean by that, there are hybrid now and other materials. There are ceramics. There's other. Does that matter?
It does. And there's some pitfalls connected with it, and there's some real positives to it. Let me talk about the bearings in general. There is standard bearings Then you have ones that are coated on the outside with a non-conductive coating called insulated bearings. And the third type would be something called a hybrid bearing. And that's where you have a ceramic ball that separates the inner and outer race. Um, all three of them do the same thing. They reduce the rotational friction on a motor so it runs smoothly and effectively. The problem here is that say you took a motor that you were having a problem with and you put two insulated bearings into it saying, I'm going to fix this problem with my motor. And this is an actual case from Irving Paper in Fort Edward, New York, where they took a 600 horse roller motor, and paper mills have lots and lots of 600 horse motors in them. And they were having problems running this on a VFD. So they asked a bearing wholesaler. They said, "How do we fix this problem?" So the wholesaler came back and said, "Hey, just put two insulated bearings into it." Well, once they put two insulated bearings into it, the energy that was still being collected on the shaft, and the rotor, ended up going down the shaft through the coupling and into the gearbox. So they were failing a $50,000 motor before. When they put those insulated bearings in 2 months, they failed a $250,000 gearbox simply by not pulling that charge off of the rotor. So if you use insulated bearings, always use a shaft grounding ring. That way you don't allow that electrical energy to flow around.
Wow. So, man, seriously, you make that mistake once, and then you learn. You learn with
Yeah,
which
that's right. You will never put insulated bearings in without a shaft grounding ring.
never. Oh God. Well, that's interesting. I was kind of poking around again. I looked at some of our here. I'm just going to pull it up. As you know, Aegis is a partner of ours. So is folks like ABB. And I'm just kind of going through here, and literally everybody that I see could probably benefit from your product. Every one of our partners. There you guys are right there. Yeah, and we've done a lot of great things with you guys over the years. There's some articles and some examples that you can see on the Empowering Pumps website, including some white papers and some case studies here. So I love it. And here's some good examples that you can see right here on the partner page. So good resources available if folks want to do a little bit further exploration. How do they get a hold of you? And do you actually make calls yourself, or do you have people that do that? I mean, how does that work?
Both. I just came back, from traveling. Um, Everybody at Aegis or Electrostatic Technology, um, we are always looking for new ideas, but a lot of the new ideas come from the field. So rather than sitting in the office and telling people what to do, we get involved with it also. Um, it is not a hard thing to do. As far as contacting us, you can go out to the website, just type in AEGIS, AEGIS, shaft grounding rings, and the website comes right up. Availability is the white papers. But if somebody contacts us and says, "Hey, what about this?" Typically, I will call them back and we'll have a kind of a far reaching discussion about everything that they're experiencing. So, yeah, we take the personal approach. We would much rather have personal contact, and doesn't mean that we are going to end up in every facility. It simply means that we're always available to talk about the needs of the customer when it comes to shaft grounding.
That's fascinating. So you really do have a hands-on approach and a bit of a Socratic sales technique, meaning you ask questions, and if it really is a fit, then you move forward. So let me ask you about that. Are there instances where it isn't a fit? I mean, the VFD is certainly a factor, but if I'm not using VFDs, does that make it not a fit, or is it still something that is advisable? I mean, I guess it's okay to say this is my market segment and this is not. So where don't
Here's a
let's
couple other examples of how this will function.
sure, sure.
Besides running a motor on a VFD, there are many manufacturing processes with products like, well, let's see, non-woven fiber, which would be kind of a baby diaper type of situation. These are highly static charge products.
Yeah.
And if you don't take care of that static, it will simply look to pass to the bearings. And once it does that, then you're just creating a problem for yourself. So it doesn't matter whether you are doing something about um, uh, molding in plastics or manufacturing mylar or even things, and I'll give you a good example.
Okay.
Something as simple as a bandage that when you go and you replace, I mean, when you go and manufacture a bandage, there is a fair amount of static that's built up in there. Well, and the way you know that is that when you pull the paper off of that bandage, it wants to stick to your hand.
Yes.
Not the bandage part, but you got to kind of shake it to get off your hand.
Right.
Well, it's manufacturing static. And what they do is they actually take that off the product. So it makes it more consumer friendly. And at the same time, you static can create all kinds of problems when you manufacture. So they try and get rid of that. So there's another type called electrical erosion. Electrical erosion happens a lot in pump motors and those kinds of things in the seals. So by stopping this, it will actually create a more profitable situation for companies.
Okay. So interesting. So even instances where there's no VFD, but the substance creates electrostatic charges, you can help
Correct.
diffuse that as well. Fascinating. Okay. Any other stories you want to share? I mean, I like the success stories where you march in and go, here's how I've saved the day. I mean, and is there any dollar amount that you said, I walked into brand X and saved them $100 million a year? I mean, is there any stories like that? I mean, and also my mind is blown that the next time you go to Mars with this little exploration device, it's going to have your product on it. I mean, what a feather in your cap there. I mean, it's so cool.
There's a lot of things that are not on this earth that actually have AEGIS shaft grounding. The satellites that circle the earth, they all have solar panels on them. And in order to make the solar panels work properly to recharge the batteries in there, you need to point those solar panels at the sun as it's rotating the earth. So that means that you have to be able to move those solar panels. You don't want to move the whole um, uh, uh, device. You want to move just the solar panel to get the optimum charging. Well, that solar panel needs to have a motor in there, and that motor is controlled with a VFD. So if you should have satellites up in the atmosphere, they are going to have shaft grounding in them. The space station, same thing. They have solar panels that charge all the batteries and that kind of stuff. They have to keep those pointed at the sun because they don't do any good unless you get full sun on them. So they have shaft grounding there also. So there's lots of different types of products. Here's an interesting one for you. We work a fair amount with the armed services, Navy, Air Force, Missile Defense Agency, all kinds of branches, Marines, that kind of stuff. Had a call from the Marines, and they said, "Hey, we're having a problem with our Bradley fighting vehicles." And I'm like, "I'm not sure how I can help you out here, but what do you need?" And they said, "Well, we have a sump pump in the Bradley fighting vehicle that is constantly burning itself out." So I was like, okay, first of all, explain to me why you need a sump pump in a Bradley fighting vehicle and what's it pumping out. And they said, well, the Bradley fighting vehicles are not perfectly tight, they're not watertight. So when you ford a river or ford a stream and that kind of stuff, that water ends up on the inside of the Bradley fighting vehicle, and they have a sump pump down in the bottom that as soon as it detects water, it pumps it out. You see, you have dry feed. So there are all kinds of situations. If you have motors and drives, that's the most typical place to be able to find this.
Fascinating. Well, I want to thank you. I've learned, I was actually looking at some of these videos and I've learned so much. Looking at these visuals really do help give me an idea of where uh, where the potential for problems are and how you can mitigate them using the Aegis shaft grounding ring. Uh, are there, I mean, is this the only product that's out there that does this kind of thing, or are there other wannabes that don't work as efficiently? And maybe you can talk about that. Are there folks that claim they can do the same thing that don't have that are inferior? Or how does that work? I mean, is this the only game in town? I mean, how does it, if you don't mind my
Aegis Aegis is the only product that is warranted to work. We actually have a warranty. If you take a motor, put new bearings into it, put Aegis on it, and you have bearing failure for 2 years, if in the middle of the 2 years, we actually added on to the manufacturer's warranty. The result here is that we actually have a warranty that covers that. But there are plenty of products on the market, um, carbon block, chokes, all that kind of stuff. They work, but they don't work anywhere near as well as the Aegis does. And we have a track record to prove it and back it up.
Yeah, this video was showing where it's in HVAC, it's in wind power. I mean, they're everywhere, and the
Yes.
potential for it is too. Um, Fascinating stuff, Andy. I can't thank you enough for making it a little bit more clear. I've heard about it, I've seen it, but now I didn't know the VFD was such a contributor as well. But the more I think about it, and again, I'm just your average guy in the street. VFD is necessary to make the transition from stationary to moving gentle on a motor. I mean, if you have a motor that's a huge motor, you don't just flip a switch and it just goes on. You have to have that variable frequency drive to gently bring it up to speed, if I'm not
Mhm.
mistaken. Would you say
Right.
that's the application there? So, otherwise it's just on or off and it's very
That's correct.
dramatic,
Yes.
you know. So VFDs are a critical component for motors. Like it or not, you have to have those. So if you have a VFD, by default, you got a 50% chance of having uh, electrostatic issues, and you can mitigate them very quickly using the ring. So it's a it's simple yet it's complicated. Fascinating story.
Well, Vince, I really appreciate you taking the time to do this. Thank you.
I've learned a tremendous amount, Andy, and I appreciate it. We're going to put your name and information and how to get a hold of you in the video, and really looking forward to. Sorry, duty calls. Somebody was calling, but yeah, we'll put your name and information out there, and look forward to seeing if we can steer some more people your way. The whole purpose of the Lunch and Learn is to record something like this to share, not only for today's generation but for the future. If somebody plugs in on a search engine that they have an issue, I want to be able to bring it up and share it with them. And it may be, if it's somebody that's completely green to the idea, at least they know that something like this is out there. And I imagine that if you're a seasoned engineer, you probably already know about how great the product is. So, but this is just sort of a learning tool. So that's what the whole purpose of the Lunch and Learn with Vince is. So thanks again, and we'll talk to you soon.